Next topic is Colpitts oscillator. So again, the Colpitts oscillator is nothing but an LC oscillator which contains two capacitive reactance and one inductive reactance. In the feedback network, we call it as a Colpitts oscillator. Now we will concentrate on the circuit diagram. So now look at the circuit diagram. If I compare this with the Hartley oscillator, the only change here is here two capacitors are used and one inductance is used. There two inductance and one capacitor. Here two capacitors, one inductance. Only that is a primary change between the Hartley and Colpitts oscillator. Here two capacitors are connected in series, okay, with respect to inductor. Again the same explanation here, the transistor with three resistors R1, R2 and RE and RFC choke is here, two coupling capacitors and one bypass capacitor C. So this is a voltage divider bias which generates 180 degree phase shift. This is a tank circuit. By selecting the values of C1, C2 and inductor, again generates 180 degree phase shift. So the total phase shift generated by this circuit is 360 degree. Okay, so you can say that the circuit oscillates and generates the waveforms. Now look at the equation here, that is a frequency of oscillation. F naught equals to 1 divided by 2 pi square root of L into C equivalent, where C equivalent is nothing but C1, C2 by C1 plus C2, because two capacitors are in series, hence this is the formula for C equivalent. So the condition for sustained oscillations means the HFE value, that is beta current gain, should be greater than C2 by C1 to satisfy the criterion, that is Barkhasan criterion, magnitude of A beta should be equal or greater than 1. A similar explanation is done also using FET here, only the change is BJT is replaced by FET. Again the remaining explanation is same which is explained earlier. Okay, so now here we will focus on one problem based on Colpitts oscillator. So look at the problem here. So in a transistor Colpitts oscillator, C1 is 1 nanofarad and C2 is 1000 nanofarad. So find the value of L for the frequency of 100 Hertz. So 100 kilohertz. So here all the values are given. Use this formula which is belongs to the Colpitts oscillator. F equals to 1 by 2 pi square root of L into C equivalent. So first find the C equivalent using this, okay, and then substitute this value in here and rearrange the equation and get the value of inductance value. So which is here L equals to 2.5355 millihenry. Once you got this answer, the problem is completed. Similarly, another two problems are solved here based on Colpitts, and there is one problem which is solved here based on Hartley oscillator. In the Hartley oscillator, just inductance values are given, 2 millihenry and 20 microhenry. They ask you to calculate the range over which the capacitor to be verified or varied. So given frequency is 950 kilohertz and 2050. So first find out the values with respect to frequencies given, substituting in the same formula which is for the Hartley oscillator. Just go through this, you will understand. So two capacitors value you found. Now the range starts from 2.9 picofarad to 13.89 picofarad because two frequency values are given. Okay, so like this we can solve the problems based on oscillator. Thank you.